For RCR TV, I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, small cell, Wi-Fi, and much, much more.
CommScope, thinking beyond today's technology to help you make the best decision for your network and your business. Telecom Careers, the #1 global telecom and wireless job board. telecomcareers.com.
Welcome back to HetNet Happenings. You know, recently former FCC Commissioner Jonathan Adelstein, who is now the CEO of PCIA, the Wireless Infrastructure Association, referred to New York City as the wireless envy of the world. And naturally, that got our curiosity up here at RCR, so we wanted to sort of dig into that statement. Fortunately, we had a good opportunity to do that at the recent Telecom Exchange event up in Manhattan. Our CEO and editorial director, Jeff Mucci, had the opportunity to discuss this issue with a number of telecom industry leaders. In this first clip, Jeff's going to speak with Christopher Fisher. He's the president of the New York State Wireless Association. So let's take a look at that clip.
So Chris, last week at your event, New York State Wireless Association event, Jonathan Adelstein, who is the former FCC chairman or FCC commission and also the CEO of the Wireless Infrastructure Association, he pronounced that New York City is the wireless envy of the world. What do you think, or who do you think is really behind putting New York City on as the envy of the world in terms of wireless?
New Yorkers, of course. New Yorkers are fast-paced. It's all about mobility. So I think at the end of the day, it's New Yorkers who are putting wireless on the map here, and why New York is the envy of the world in terms of mobility.
So it's a bottoms-up movement.
It is. It's a bottoms-up movement, and I think at the end of the day, that's who this industry is trying to serve. So ultimately, it is about the consumer.
All right, now, talk about your own experience. How many bars do you get when you walk around the city of New York? What do you think about your service?
Interestingly enough, I actually do have a pretty robust service, and as I was coming down today to this event on the subway, I was amazed at some of the work some of the companies have been doing to deploy in the subway, how far they've actually advanced in the last couple of years, and how robust the system is in a subway. Subway system that's 100 years old, think about the construction challenges involved in trying to do that. So there are areas, of course, in New York City, given you've got upwards of 8-9 million people who live here, where you're going to have a challenge, and I think there's still work to be done. But ultimately, these are some of the most robust wireless networks in the world.
Great. Thank you.
You bet.
In that clip, you heard Christopher mention that in New York City, they even have cellular coverage down in the subway system. So even aside from the novelty fact of extending high-tech infrastructure into a 100-year-old subway system, you've also got a really, really complicated deployment scenario with the propagation patterns underground there. So that really is quite a feat. Fortunately, we got an opportunity to get down into the subway system with Mike Coyato from Solid. Solid's a DAS and equipment provider, and we also spoke with Nathan Cornish, who's the director of RF engineering for Transit Wireless. We got a really detailed look at some of the deployments down in the subway system that we'd like to share with you now.
This is a really challenging environment for wireless. First of all, you're subterranean. How do you get coverage down underground in the subway system?
As you can see, the trains just don't stop coming. So one of the significant difficulties with the subway is it is 24/7, which we're seeing behind us.
You're going to get a crowd of people that are going to just slam the capacity of the system. Then they're going to get on a train, they're going to go away, and then the process repeats itself. So you need to design a system that is able to provide those capacity spikes.
So what we're going to be showing you is the components of the DAS and the Wi-Fi network, which includes the antennas and the Wi-Fi access points that are above us, as well as the remote node that Solid's provided. These are the essential parts that provide the service in the subway.
One of the interesting things architecturally that Transit Wireless has done in their design is, given the limited space of the subway tunnels, is to use base station hotels as a way to organize the head-end equipment in a way to serve multiple locations. It's a way of getting around the challenges of limited space.
So what is a base station hotel? Because I've heard that term a lot in the last 2 weeks, but what does it really mean?
Yeah, it kind of is what it sounds like. It's literally a location where you hotel or you group the base station head-end equipment from the wireless operators as well as the DAS OEM in this case.
The carriers themselves like this because they can bring their techs to this one location. They're not in the subway working on the equipment. So what we're looking at here is this is one of the Tier 1 operators' base station equipment. This is a typical base station that you would find in any base station for a tower or top of a building. Inside this equipment is their GSM, their 3G, and their LTE equipment. Each one of these base stations, which holds up to 3 sectors, will be feeding 3 different stations throughout the network. So this location can hold 60 sectors, which in our terms is 60 stations. So from this point on, you can see that there's a significant amount of fiber that comes in, and this is the backhaul equipment for the carriers to bring into their base station. From this point on, this is actually the RF component, as if we were going to the top of a tower onto antennas, but from this point it's distributing over to the head end equipment. These are what we call DAS trays, and essentially the carrier equipment comes in at a high power level, and the equipment that goes for our head end is actually a low power level.
So those big cables from over there, those were
for high power coax cable.
High power, it's got to come in here and you got to step it down.
Yeah, so these essentially are stepping down from the carrier high power, taking away significant amounts of power down to the low levels that's required by the head end. So each carrier will have similar sort of equipment, and the advantage of this, these trays also give you the ability to adjust the levels into the head end equipment, but also make additional optimization on the uplink side when there's a different noise floor in the station. This is now the head end of the facility. So this is essentially the central component for every single station. So this is where we take the inputs from every carrier, so from 2G, 3G, and 4G, and combine them into a system that we can communicate to the station. So what we're looking at here is each rack is essentially 2 stations. So his station number references to the MTA's association for a station. So this may be 33rd Street or something like that. And then each sector has each technology inside it. So
you have different boxes for each carrier, or are you actually aggregating multiple carriers into one box?
It all aggregates into the same box, but essentially the system is broken up into bands. So obviously on our system we have 700, we have 800, we have 850, 1900, and 2100, and we'll keep expanding that. So the advantage of this system is it's flexible enough to add different bands and add different carriers to the network. From this point on, there's a single fiber that leads to whichever station this is connected to. This is the massive amount of batteries that they provide to protect their equipment. So essentially, the power to this building was to go down. We wouldn't want to lose all the equipment in this building because that would affect what's in the subway. You can see there's a significant amount of equipment here, and this is extremely heavy equipment, so all the flooring has actually been reinforced with steel to ensure that it's held up inside this building.
So Nathan, this is our last stop on our transit wireless tour. Talk about how the fiber comes in, the fiber goes out, and what we're looking at in this room.
So obviously, feeding fiber from this room needs to go out into the street. So from this point, the head end connects into fiber distribution frames that converts onto our 864 fiber that goes out into the street. So as you can see up above here, this is actually, it doesn't look like it would hold 864, but this is 2 reels of 864 fiber. So from this point, you'll see this cable runs both into the transmission room or the base station hotel, and then it runs down the conduits down through the floor into the street. So the fiber from this point is actually running through the conduits in the street and in the building.
So how many bars do you get on your phone? We're down the subway.
I'm at full bars right now. Yeah.
And are you happy with your phone service?
Yeah, I'm extremely happy. I'm able to call, I'm able to text, I'm able to go on Instagram, Twitter.
So obviously, extending cellular into a subway is a really difficult use case, but you know that's just the tip of the iceberg as far as cellular's challenges in a big urban metro environment like New York City. You consider 8 million people, the vast majority of them connected with a mobile device of some sort, moving around and sort of changing those capacity loads. It really is an interesting use case with a lot of challenges. In this next clip, Jeff is going to speak with Greg Weiner. He's a partner at Vertex Consulting, and Greg's going to detail some of the New York specific challenges to wireless.
One of the closing questions was, we have heard and it's been pronounced that New York City is the wireless envy of the world. What's your response to that comment, and who do you think's behind it?
Yeah, having deployed a DAS network here in the city, I'm honestly I'm surprised to hear that, and also just walking up and down the streets here and seeing and knowing what I know about how difficult an environment is this is to deploy a wireless network. I'm really surprised to hear that. My assumption is that comes from somebody in the New York City government or New York, somebody who's got a vested interest in claiming as much. But it's a challenging environment, like a lot of others, of course. But this brings certainly in the U.S. a whole set of unique challenges that we don't see anywhere else.
For example.
Well, building heights, trying to provide high capacity and thorough coverage at street level on the 20th floor and on the 40th floor and up all the way up to the 80th and 90th floors, right? Phenomenally difficult to do these multi-layered networks, reusing spectrum, dealing with interference from one layer to the next, handoffs. It's a really tough environment, not to mention from a siting and zoning perspective. You've got some of the most sophisticated landlords in the world here. And a lot of our speed and deployment elsewhere in the country is premised on having rather unsophisticated landlords. And then you've got everybody with their hand in the kitty, whether it's the government, business improvement districts, conservancy boards. I mean, everybody's got an opinion on whether and where the sites should go and what they should look like.
And does that apply to in-building as well as macro and micro small cell networks, and even how about Wi-Fi networks?
Yeah, so in-building is obviously more focused on the landlords,
yeah.
and the difficulty in deploying in a lot of older buildings. You don't always have the access to the risers and the point of entry. They're more challenging environments to deploy in for sure. Wi-Fi, similar challenges. You're as with any of these, whether it's a macro or small cell, Wi-Fi, in-building, backhaul, power, the same kinds of challenges you're going to have across all of those.
Okay. In these multi-layered, up, down, tail, how do you optimize? How do you build those kind of networks?
A little bit of everything, right? You've got the top pointing down, you've got the midpoint pointing down, you've got street level coverage. You hope to have a really strong spectrum position so you can mitigate interference as much as possible.
So obviously a lot of action around wireless up in New York City, and we just took a peek at a few different sort of examples of that. This is something that RCR covers fairly regularly. For instance, Mayor Bill de Blasio's office is in the process of converting 10,000 antiquated phone booths into public Wi-Fi hotspots. That's sort of an interesting use case because that phone booth is connected already to the same infrastructure that Wi-Fi would need, so it's really an efficient sort of upgrade process that keeps down your capital and operational expenditures throughout that transition. Another interesting item we wrote up recently pertaining to New York Wireless was the installation of Wi-Fi hotspots on municipal garbage and recycling bins. So really a lot of action going on in that space. And for a lot more from our trip to Manhattan and from the Telecom Exchange event, I'd encourage you to take a look at the RCR Wireless News YouTube channel. And to keep up with daily IT, ICT, and telecom news, you can visit rcrwireless.com. You can even subscribe to our newsletter and get that delivered to you every day right in your inbox. And for lots of other great RCR TV content, including back episodes of this program, you can visit the RCR TV website. Thanks for joining us on HetNet Happenings, and we'll see you next week.
HetNet Happenings is a production of RCR TV. To reach Sean Kinney or to suggest a show topic for HetNet Happenings, you can reach Sean at skinney@rcrwireless.com, on Twitter at SeanKinneyRCR. To find out more about the latest in HetNet and all things wireless, dig into rcrwireless.com.